Welcome in. This is 7.6 on factoring. It's part 2. And this is really just a refresher of part 1, which we did last week before we go and start the big ideas. It's a tougher topic. So I wanted us to re-engage with this for another day. It's not necessarily like a new idea, but it's just kind of re-engaging with the stuff we started last week. So stay tuned for the learning here, and we're going to try a few problems together. All right, so where we started in 7.5 is looking at some problems like this, factoring the trinomial, where we had x squared plus 7x plus 10. So when we did that, we would do the box. The first term goes in the first box, the last term goes in the last box. Then I would need two numbers that are going to multiply to 10 in that last box and add to 7 in the middle, right? This is going to be x and x. So I need two numbers that multiply to 10 and add to 7. What are those numbers? Enter your answer when you're ready. Yeah, hopefully you said 5 and 2. Really, your only options for multiplying to 10 are 5 and 2 or 10 and 1. And 10 and 1 is going to make 11. This one's going to make 5x and 2x, which does make that 7x. So our answer would be x plus 2 times x plus 5. So again, that's kind of where we started in 7.5, but if we can't do 7.5, then we're not going to be able to do 7.6. So go ahead and try B here, x squared plus 9x plus 14. So go ahead and try that one. Again, you're going to need to draw down a box in order to do it. Factor the trinomial and enter your answer when you're ready. So the key here is the two numbers that multiply to 14 and add to 9 are 7 and 2. So we have a plus 2 and a plus 7, so 7x and 2x is going to add to 9x in the middle. And my answer is x plus 2 times x plus 7. So I'm hoping at this point that we are proficient at problems where we have just x squared in the first box. And that's what section 7.5 is all about. This box being x squared, my first term being just 1x squared. You have the invisible 1 in front. 7.6 is all about when you change that number in front of x squared to something other than 1. And we started practicing that last week, and we're going to continue practicing that today. All right, example 2 here. This time we are looking at a problem with a number in front of x squared. So in this case, the number is 2x squared minus 5x minus 7. And the problems are a bit more challenging when we have a number in front of x squared like that. But the procedure is still the same. I'm still going to draw down my box. And the first term, 2x squared, goes in the first box. The last term, minus 7, goes in the last box. And I have to figure out what goes on the outside that's going to multiply in. The nice thing is on this one, I don't have too many options because my only option for 2x squared is 2x times x, right? So even though it's not just x squared, I kind of can just put in 2x and x there. And then what I'm left to do is I want these two boxes here to add to negative 5x. And I need the two numbers out here to multiply to negative 7, right? So my options now are either 1 and negative 7 or negative 1 and 7, right? Because when I'm ever multiplying to a negative, I need one positive and one negative. But I also have to think about this. I need to have, that could be a 1 here, and then it would interact with the 2. Or it could be a 1 down here, and then it would interact with the x. So it's going to be different depending on if I put the 1 up high or the 1 down low and the 7 up high. So I have to think about my order as well now that it's not just x and x. So kind of what I like to do is I usually just kind of try things out. I'm noticing that I have a negative 5 in the middle, so I'm probably going to want more negative. So I'm going to pick this one because I'm probably going to end up wanting more negative to make that negative 5 in the middle. If I pick a negative 1 and a positive 7, I'm probably going to end up with more positive numbers when I add. So I'll just try 1 and negative 7 and see what happens. If it doesn't work, I'll flip them. If it doesn't work, I'll try the other pair. So for a plus 1 and a minus 7, I'd have a plus 1x and a minus 7, or sorry, not minus 7x. Minus 7 times 2 makes a negative 14x. And negative 14 plus 1, right? I have negative 14x plus 1x. What does negative 14 plus 1 make? Go ahead and calculate that and enter your answer when you're ready. Yeah, that would make negative 13, right? I have 13 more negative than positive. And that's not what I wanted. It doesn't match the negative 5x in the middle. So I know that negative 7 up top and plus 1 down low doesn't work. But I can still flip them and see. Maybe it'll work if I flip them, maybe not. If it doesn't work once I flip them, I'm going to have to try the other pair. If I try the -7 down low, now it's just interacting with a regular x, so -7x. And now 2x is interacting with 1. 2x times 1 is a +2. And again, off my plus minus chart, -7x plus 2x, I'd have 7 negatives and 2 positives, which makes -5 in total, which is what I want in the middle. So I know my answer would then be 2x minus 7 times x plus 1. One other thing we mentioned last time is factoring when there's a GCF, and we haven't seen those in either of the first two examples, so it's good to bring that up because we're going to need to know it for the big ideas. We did talk about it last time, and what a greatest common factor is when there's a number that divides all three of the numbers. In this case, 8, 10, and 12 can all be divided by 2. Since 8, 10, and 12 can all be divided by 2, I can factor a 2 onto the outside and then reverse distribute it back in. 2 times 4x squared makes 8x squared. 2 times a minus 5x makes a minus 10x. And 2 times a minus 6 makes a minus 12. All right, now once I'm here, I need to factor what's left on the inside. So this whole piece here on the inside, that's a trinomial that can be factored. And again, it's in the form ax squared plus bx plus c, where I have a number in front of x squared. So I can use the box, but it is going to be the trickier type where I have a 4x squared in that first box, the minus 6 in that last box. So I have quite a few options here. For 4x squared, I have 1 and 4, or 2 and 2 for the x squared part. So there's a couple options there. And then for the -6, I have 1 and 6, but it's a negative, so -1 and 6, or 1 and -6. And then I have 2 and 3. And again, I could have -2 and 3, or I could have 2 and -3, right? So you may have to try multiple different options of things before you get it to work out right, and that's okay, right? I'm going to start with 1x and 4x here. But it may be 2x and 2x, and then we're just going to have to go through all 4 of these options. If all 4 of these don't work for 1 and 4, then I'll know that I need to flip it to 2 and 2, right? So I'm going to start with 1 and 6, then I'll try 2 and 3. If I try a -1 and a +6, that would give me 24x and -1x, which doesn't work. Even if I flip that sign to a +1 and a -6, 24 and 1 are still too far apart. So even if I was a +1 and a -6, that would just make this negative and this positive, and that's still not going to work, right? So that's not going to work with a 1 high and a 6 low. But it could work with the 1 and the 6, right? Because now I'd have 4x and 6x. But either way, if I make this one negative, that would make -2. If I make it positive and this one negative, that would make +2. So either way, that's not going to add to the -5x that I need in the middle. So it seems like 1 and 6 didn't work with 1 and 4, either up high or down low. So we kind of know that's not going to be the one now. And so what I can do is I can instead try 2 and 3. Whoops, I don't want green. 2 and 3. And in this case, I'd have 8x and 3x. And so like say I made this one positive and this one negative. I have a +8 and a -3, which 8 and -3 adds to 5, which is very close. I do have a 5 on the green, but I have a -5. So I really need those boxes to add here and here to -5. And I would be able to do that if this 8 was a negative and the 3 was a positive, right? So if I had -8 and +3, I'd be able to do it. And I would have had that if I had put +3 and -2, which was another one of my options, right? So -2 times +3 does make -6. And then I get -8x in this box and +3x in that box, which does add to -5. So I found it. I had to go through quite a few options, but I did find it, right? And my answer would be x minus 2 times 4x plus 3. And then, of course, since I had that GCF here, I have to bring that down and keep it in my answer. So I'd have 2 times x minus 2 times 4x plus 3. So that's kind of how you do one with the GCF. Those do come up, and we talked about it last time, but just to kind of re-engage with that, we'll remember to take the GCF out throughout today. All right, we're going to try the last one. You're pretty much going to do this one. First things first, does this one have a GCF? 3x squared plus 11x plus 6. Is there a number that divides all three of those parts? Enter your answer when you're ready. Yeah, no GCF on this one, so we're just going to be straight factoring with the box. I have 3x squared in my first box. I have 6 in my last box. Of course, for 3x squared, you'd have just 1 and 3 as your options, but for 6, you'd have either 1 and 6 or 2 and 3. Try out the options, try to make it work for 11x in the middle. Factor the polynomial and enter your answer when you're ready. So 3 and 2 are kind of the key numbers here. You end up with 9x and 2x when you do that. And we're left with the factored form of 3x plus 2 times x plus 3. So we should be ready to try the big ideas. We kind of had 2 different chances for us to engage with the factoring problems on section 7.6. Hopefully you're ready. Go ahead and try those big ideas, and I'll see you next time.